is Norjanah from BSc 3A. Our topic for today is rotational motion. Rotational motion can describe that any object that can rotate or spin, or it rotates around the fixed axis in a circular motion. For example, this object rotates in a circular motion or clockwise motion, and this reference or this axis, we use this as a reference or starting point of an object. And later on, it moves the object and the distance will change, and this distance we call this as our angular velocity. And theta is for angular position, and alpha or omega is for angular velocity, and alpha for angular acceleration. And for definition, the omega is change of theta over change of time, and alpha is a change of omega over change of time, and for differentiation is a d theta over dt and d omega over dt. For example number 1, we have a wheel is rotating freely at 1,800 RPM clockwise. It is subjected to a variable counterclockwise torque, which is first applied at the time t is equals to 0. The torque produces a counterclockwise angular acceleration alpha is equals to 40 rad per second squared, where t is the time in seconds, during which the torque is applied. Calculate A, the time required for the wheel to reduce its clockwise angular speed to 900 RPM, and B, the time required for the wheel to reverse its direction of rotation, and C, the total number of revolution clockwise plus counterclockwise turned by the wheel during the first 14 seconds of torque application. For letter A, ang hinahanap natin is the time required for the wheel to reduce its clockwise angular speed to 900 RPM. So, meron tayong given na initial angular velocity, which is dito is 1,800 RPM, and the given for letter A is 900 RPM, which is the final angular velocity. In this problem, we assume the clockwise is negative and the counterclockwise is positive, so that the sign for this is negative since the given is clockwise. And the unit of the given is revolution per minute. We have to convert it into radius per second to satisfy the unit. So, in 1 revolution, we have 2 pi rad, and 1 minute, and in 1 minute, we have 60 seconds, and in equals to negative 60 pi rad per second. And for final angular velocity, negative 900 RPM converted into rad per second, or 2 pi over 60 seconds, and equals to negative 30 pi rad per second. Since ang hinahanap natin yung is time, and the alpha and can integrate, so we can use this equation and integrate the both side, and since we have initial angular velocity, so start to negative 60 pi to omega. And for time, since nag-start siya sa 0, na given sa problem, nag-start siya sa 0 and to t. And kapag in-integrate natin to, we can get the omega and minus negative 60 pi is equals to 2t squared. So, 4t divide 2 na lang yun. And transpose the 65 and plus 2t squared. Since may value tayo ng omega, which is the final omega, this negative 30 pi, substitute natin dito, and makukuha na natin yung t. And square root of the value of this, and that time is equals to 6.86 seconds. The time required for the wheel to reduce its clockwise angular speed to 900 rpm. So that's the answer for letter A. And for letter B, the time required for the wheel to reverse its direction of rotation. So, yung wheel daw dito is nag-change ng direction. So, yung omega natin, papalitan natin ng 0 kasi the omega is momentarily 0 na siya. So, gagamitin ulit lang natin itong equation and substitute the omega na 0. So, negative 65 plus 2t squared, and makukuha na natin yung t squared plus 60 pi over 2 t squared square root and square root to 35, and t is equivalent to 9.71 second. And for letter C, and the total number of revolution clockwise plus counterclockwise turned by the wheel during the first 14 seconds of torque application. So, ang hinahanap dito is the total number of revolution. So, using the total number of clockwise turn and the counterclockwise turn. So, we have to get the total clockwise turn and the counterclockwise turn. So, ang N1 natin is equivalent to CW or clockwise. And we can use this equation. Since ang hinahanap natin is revolution, the revolution is the distance or angular distance. And we can use this equation. So, omega is equals to d theta over dt. And d theta is equals to omega dt. And start sa 0 theta. Since etong omega is nag-start sa 0 to 9.71. Yun yung time of clockwise. So, 0 to 9.71. So, 0 theta. And substitute lang natin yung value of omega or yung W, which is the negative 60 pi plus 2t squared and dt. So, 9.71. And theta natin, kung in-integrate natin to, theta is equals to theta 1. And if we integrate this, makakaroon tayo ng 60 pi t plus 2t 3 raised to 3 over t and 0 to 9.71. And substitute natin itong 9.71 dito sa t and dito sa t, we can get the 1,200 rad. Since ang hinahanap natin is revolution, we have to convert the rad into rev. So, divide na lang natin siya into 2 pi. And we can get, and the value of N1 is equals to 194.2. Theta 1 is equals to N1, and the answer is 194.2 revolution. And for N2, or theta 2, gamitin lang din natin tong equation na nakuha natin dito, but the time will change. Kasi bumalik na siya, or nag-counterclockwise na siya. No, nag-start siya sa 9.71 to 14 second. So, substitute lang natin tong 14 sa t, and 214 is to 3 over 3 minus, i-substitute naman natin itong 9.71 sa mga p. 3 squared over 3 and minus, so itong value na to is negative 809.60, and this equation is the value is 1219.96, and the total is 410.36 rad per rad. And rad pa siya. So i-convert natin to into rev. So divide lang din siya sa 2 pi and magkakaroon tayo ng 65.31 revolution. And the total of number is 194.2 plus 65.31. So, sinag-substitute lang natin yung nakuha natin dito na value. So, nakuha na natin yung total of number of revolution, which is 259.52 revolution. So, that's the topic for today. Thank you.